Welcome to doassignment-ca. Here is the problem. A boat starts from rest at a position of 0 feet and travels in a straight line. Its acceleration varies with position according to a piecewise linear graph. From 0 to 100 feet, acceleration decreases linearly from 8 feet per second squared down to 6 feet per second squared. From 100 feet to 150 feet, acceleration continues to decrease linearly from 6 feet per second squared down to 0. Determine the boat's speed when it has traveled 50 feet, 100 feet, and 150 feet. Now let us work through the solution step by step. We use the kinematic relationship v times dv equals a times ds. This comes from the chain rule applied to acceleration. Integrating both sides gives v squared equals twice the integral of acceleration with respect to displacement. Because the boat starts from rest, the initial velocity is 0. From the graph, we extract two linear equations. For the first segment, from 0 to 100 feet, the acceleration equals 8 minus 0.02 times s in feet per second squared. For the second segment, from 100 to 150 feet, the acceleration equals 6 minus 0.12 times the quantity s minus 100. At 50 feet, we integrate the first segment's acceleration from 0 to 50. Evaluating the antiderivative gives v squared equals 2 times the quantity 400 minus 25, which equals 750. Taking the square root, the speed is approximately 27.4 feet per second. At 100 feet, we integrate the same first segment formula from 0 to 100. Evaluating gives v squared equals 2 times the quantity 800 minus 100, which equals 1400. The speed is approximately 37.4 feet per second. At 150 feet, the path crosses into the second segment, so we must split the integral at 100 feet. The first part, from 0 to 100 feet, already equals 1400. For the second part, we integrate from 100 to 150 feet using the second segment's acceleration formula. Evaluating the second integral at the bounds gives 2 times the quantity 750 minus 600, which equals 300. Adding both parts, v squared equals 1400 plus 300, or 1700. Taking the square root, the speed at 150 feet is approximately 41.2 feet per second. Summarizing the results, at 50 feet, the speed is 27.4 feet per second, at 100 feet, it is 37.4 feet per second, and at 150 feet, it reaches 41.2 feet per second. The speed increases throughout the entire motion because the acceleration is always positive, even as its magnitude decreases. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.